for next 5 minutes, and then you'll continue. Okay.
Sure.
Yeah.
All right. Hi, everyone. Am I audible?
Yes, you are audible.
You are
Yeah.
audible.
Okay, great. Hi, everyone. So I welcome you all to the DevSecOps Masters Program. So on higher demand, we have actually begun with this program. So this program is apt for you if you you have the knowledge about DevOps. So mostly the next step after DevOps is DevSecOps if you want to learn more about security and learn high and valuable skills for the industry. So let's begin with a quick question. So so who would you prefer learning from mainly? Someone who is a trainer or someone who is an engineer? Can someone unmute themselves and answer me? Who would you prefer learning from?
I can speak if is it okay?
Yeah, of course, of course. Go ahead,
Yeah.
please. Yeah.
So what I personally feel is that we wanted, or at least I wanted, a real life example, right? So maybe people who are working on this domain and have a handful of experience, probably they can explain things and also can map it with the real world so that we understand what is happening. If you ask me, I have read a lot, but again, I'm trying to switch into the DevSecOps career, but due to not having the practical knowledge or maybe how things happen in real world, it is getting difficult for me.
Right, I completely get it, and I'm so sure about that. A lot of people would relate to you, Kamlesh, because exactly when you go and you go learn from these platforms. What the case is that there are people who are training there specifically. So over time, in such a dynamic world of IT, it's really important to learn from someone who's actually working their hands on, right? So that is what networkings we actually identified the gap in. So always, what's the case is we usually take engineers from real world, so they are already working in IT companies, big tech giant companies, and then we get them so that the students get the best quality. So if Kamlesh, as you mentioned that you wanted to get hands-on learning, you wanted to learn practically. So that is exactly you're going to get here. So on that note, I would like to introduce our trainer.
I just have one more question or maybe feedback. Sorry.
Kamlesh,
Also,
can we take the feedback like after the presentation? Is that fine with you?
Yeah, absolutely.
Definitely hear you. But let me just wind up with it. So we are all ears after that, right? All right, great. So our engineer for today is Vishal. So he's been working in the industry for more than 5 years. So he is a cloud security engineer. So of course he has multiple certifications. Some of them are AWS fundamental and also AWS security. So of course you'll get to learn a lot from Vishal. Here you can see he's jack of all trades here. Okay, so today, since it's an introductory session, so you're going to learn what actually is DevSecOps and what the industry demands in the field of DevSecOps, what are the skills that you require, how you can build a career in it, everything would be covered. Vishal would definitely take all your queries. So this is definitely going to be an interesting session. You're going to learn what actually goes into the industry and how people are, thriving to get on the top of the DevSecOps industry. And you'll also learn what are the various career opportunities that you can get in the industry for sure. Okay, so there are some of the few student testimonials, students who have, learned from us. And these are some of the students who have actually, transitioned mostly from a non-tech career into a tech career. So all of them usually had their, full-time jobs and they have still upskilled with us and they have learned a lot. So that's all from me. Kamlesh, you had a query, right? You can unmute yourself if you want to, address it.
Yeah, just one thing. if we don't know much about DevOps, then what?
Okay, so since it's a technical question, I'm very sure Vishal would be able to, address your problem, and you can definitely talk to him. It's going to be a productive session for sure. So I'll ask, Vishal to take over here so that he can resolve your queries, and I'm sure you'll all be satisfied with this one. Thank you so much. Over to you, Vishal.
Sure. So, Kamlesh, I will be answering your question while presenting the PPT. Your question will be answered for sure, and you will understand why it's not really highly important to know DevOps before starting the DevSecOps. So, but even in the DevSecOps, I am going to provide few DevOps stuffs as well. So, the thing which required from the DevSecOps perspective, I will provide everything to you. So, no worry in that. So let me introduce myself. So as Akriti already has introduced, but still I'm Vishal, almost 5 years of experience in this IT industry, where I have experience in cloud security, DevSecOps, and application security as well. So Akriti, can we get started
Of
with the
course,
PPT?
Yeah,
sure.
So today our topic is DevSecOps, and nowadays it's pretty getting famous in the industry. Now, not only the small organization, even the big organization like Google, Amazon, Meta, all these have this DevSecOps profile in them. Earlier, the DevSecOps profile was introduced just to handle the security of the pipeline. Now, the DevSecOps also take care of the cloud security. So let's go deep into the DevSecOps and let's understand the future of the DevSecOps first. So I will provide the definition of the DevSecOps later. So, if you go and search on the internet, you will find out that the DevSecOps market is about to grow at the rate of CAGR. I'm not simply saying as normal rate, but at a CAGR rate of 32.2% between 2020 to 28%. So every year it's going around 32%. So the demand for this is completely increasing day by day, and the number of the DevSecOps engineer we have is always less as compared to the demand. So the DevSecOps is a field where you always find an opportunity to switch, always find an opportunity to grow in your career, always find an opportunity in your career to explore other fields as well. So a lot of
Hi, Vishal.
companies.
So, Vishal, there is a small question, and even there are a lot of people who's asking me, like, what's a major difference between DevOps and DevSecOps?
Yeah, I will be covering in the next slide if you
Yeah.
want. I can
Yeah,
cover
sure.
it
Yeah,
right now as well.
yeah, thank you.
Sure. So let's finish the future of the DevSecOps first, then we will go to the DevSecOps versus DevOps. So lots of companies have introduced this DevSecOps over the DevOps, and it's not a DevOps domain. I can say it's more of a security domain where the T value is there. If you consider the T letter T, you will find a horizontal line as well as a vertical line. The vertical line represent the security, and the horizontal line represent the DevOps. So the horizontal line means you should not have a depth knowledge of a DevOps, but the vertical line represent the security. You should have a deep knowledge of the security. So the DevSecOps stuff is also known as a shift left approach. Multiple interviewer always ask you what is a shift left approach and how it's related to the DevSecOps. So this shift left approach is becoming a part of day by day of the SDLC. So now the question is why you should choose DevSecOps as a career. So there are 5 points that I can cover and tell you why DevSecOps is going to be one of the critical career that people are going to choose sooner or later. So the first thing is AI safe. And when the AI got introduced in the year 2020, when this 2021, when this Chat GPT got launched, lot of people lost their job because the AI came as a revolution. Lot of HR people, lot of operation people, lot of video editors, lot of image editor, all those peoples as well as developer also lost their job because the companies want to focus more on the AI because they found out that AI is going to be the key component for them to sell their product. If their product contain AI, then their product will automatically get engaged with easily get engaged with the customer. Nowadays, the Google is launching the Gemini, ChatGPT have its multiple order for multiple models, and even small application have this AI integrated. First thing is that. Second thing is demand versus supply. Companies are hiring a lot of security engineer, but no skilled security, like not no, like half of the security engineers or the people who are switching to the security field are not that much skilled. So the demand is not getting fulfilled because the supply of this security engineer is very less. And another thing which is I want to highlight, the point number three is a competitive salary. I can share my example here. When I was working in a US company, I asked like she was having an experience of 5 year. I asked, "What's your salary? Is it 80K dollar?" And what she mentioned to me is that 80K, 80K is a very less. It's just a starting salary of an intern here. So if we take the reference of the US, then it really a competitive salary if you just for a 5 or 2 year experienced person as well. And other thing, the fourth one that I want to highlight is a higher position like CISO is there. CISO stands for Chief Information Security Officer. Security engineer have a very less competitive environment because big organization don't have a big security teams, and they have a higher and larger developer team. So to reaching a point like CISO, where you will be one of the head among the CISO, CFO, and the CMO, CEO, CTO, you will be one of the person among those people. So reaching that highest position in with the help of DevSecOps is also an easier task as compared to you are choosing a development field and then trying to go up to till the point of CTO. So another thing that is cybersecurity is a big umbrella under which multiple fields are there. Penetration testing is there, web application penetration testing, mobile application is there, forensic is there, SOC is there, cloud security, DevSecOps. These are so many fields are there. And if you want to switch a career between one field of the cybersecurity to another field, the DevSecOps going to help you because DevSecOps is going to teach you little bit of application security, little bit of cloud security, and for sure DevOps, little of bit of DevOps, and for sure you are going to become a DevSecOps engineer. Now, answering to your question, what is DevOps versus DevSecOps? You are already familiar with the DevOps. DevOps is a component which is made up of two words. One is Dev, here you can see, another is Ops. Dev stand for development, Ops stand for the operation. So these two teams come together to foster this release cycle. Nowadays, whether you use iOS or if you use Android phone, you always find that your application, whenever you go to the Google Play Store, you always find that your application have an update feature, like a new version of the app is available. Go and update it. So this release cycle has been getting faster and faster up with the help of the DevOps. So the DevOps simply mean the development team and operation team come together to faster this release cycle. So the new features can be put into the product faster and can get more and more customer. At the end goal is the money. So they want to faster this release cycle, faster of making of the functions, faster of adding the more functionalities to the code so that the user can use those functionalities and they don't switch to their competitor. So DevOps have multiple phases. One of them is planning, code, build, test, release, deploy, operate, and monitor. Here you can see the arrow is going from left to right, and then from right to left. Again, from the monitor, it's going back to the planning phase. This means this is a continuous loop. So we are going to understand each of this phase of this DevOps. So the planning phase simply means from the plan word itself, it's very clear where in this phase we are going to plan about like what are we making. If we are making for a customer, then what's the project and what the customer wants, what are their requirement, what type of different functionality they want. If we are making for our own project, then also fine. So let's take an example. It will be easy to explain with an example. Let's take an example of e-commerce website. We are making a e-commerce website like Misho. So let's imagine we are making this website. What type of different functionalities it should have? It should have an option of adding to cart. It should have a dashboard for seller. It should have a dashboard for customer. It should have an option to make payment through card, make payment through UPI, make payment through cash on delivery. So all these functionalities, which type of programming language we are going to use, which type of DB we are going to use, how our are we going to host it onto the cloud or are we going to host it onto the on-prem, and which version of the DB we are going to use? All of these things are done into the planning phase. This is a phase of the DevOps. We are discussing the phase of the DevOps. This is the first plan. After all of those things are finalized, okay, this is going to be our Python is going to be our programming language, and MySQL is going to be our DB. We are going to host it onto the cloud, AWS cloud we will choose. Then the coding phases start, where all of the functionalities, whichever we have mentioned into the planning phase, those things will get code. The DB will be integrated. The application stuff will be done on this coding phase. After that, maybe thousand of coding file can be there, thousand or hundred of coding file can be there. But if we want to ship a product to a customer, we cannot ship the whole codes, hundred of files. So what we do, we make those code into a compile those code or make a artifact out of it, or a binary file or a package or a container image. Then we ship that to the hello, UP, you have any questions? Okay, so we can continue from here. So in the build phase, what happened that your source code is compiled into a package, that the package can be used to install the application. It's not like we are sending 100 files, different files to the customers, and then they are using the app. And after the build phase is complete, then there are testing phases there. In the planning phase, whatever the requirement, whatever the function that we have think of, like, okay, the application should have these many functions, we have to test all those things. Those things can be tested with the help of unit testing, manual testing, as well as automation testing. All these testing are done into the test phase. Once the testing phase is done, the next phase is the release phase. What happened into the release phase is not the actual release. It's a reference list, or we can say a release checklist, where we check, okay, the code is working fine, all of the functions are working fine. The artifact or the package that we created with the help of the code is actually getting working into the system. Then we actually go and deploy it into the next phase, which is a deploy phase. We deploy the code into the production, and then the application start running into the application. That's a small step that we do, the deploy. The deployment can be done with the help of any CI/CD tool. Jenkins is there. Other tools are also available into the market, but Jenkins is the most famous one. After that, there's a operate phase. Operate phase is actually handled by the operation team, which take care of the availability of the application. Like, the application still exists even when the customer are using it. Maybe we thought of like 100 customer will use it, and the application or the servers will be able to handle the load of the 100 customer. But suddenly there's a spike, 500 customer came, and the server is not able to handle the load. At that time, the operation team will take care of the application and the server, and enhance the number of the server to take care of this 500 customers. So that's actually done in the operating phase, and operation team take care of that. After that, the last phase of the DevOps cycle is just to monitor for the feedbacks, availability, new request, issues, and improvement. Consider our web application, like the e-commerce application that we have mentioned, don't have a functionality of where a user can add a item to the wish list. Okay, cart he can add, but he don't have an option to add it to the wish list. This is a feature request for someone. Now consider there are some issues like, okay, user is able to add to the cart but unable to proceed with the buy. This is an issue that's need to be fixed. So all those things, the monitoring phase, from the word itself, it's clear we have to monitor the application. In the monitoring phase, whatever the issues, improvements needs to be done, those are again passed to the planning phase, where I mentioned from the monitor, it will go back again to the planning phase. And now in the planning phase, we will work on those improvement and new request, and then again the coding, building, test, release, deploy, operate, monitor. Again, this keep cycle going on. Now, coming to the question which someone asked, what's the key difference between DevOps and DevSecOps? Here in this faster release cycle, you cannot see anywhere that wherever the security stuff is getting done. Here, planning phase, are we doing any security? The answer is no. In the coding phase, are we doing any security? No. The developer is writing the code according to the functionality. The code is clean or not, we are not aware about that. The code is right or not, code contain any security issue? No, we don't know. In the build phase, test phase, we are all only testing the functionality of the function. That's all. If the function is allowing us to add the item to the cart, yes, it's allowing us to add to the cart. We are not even checking what different security issue can exist over here in the DevOps lifecycle. Then release, deploy, operate, monitor is happening. Nowhere security is mentioned. So to integrate this security, the DevSecOps come into the picture, where the release cycle needs to be faster, but it should not be that much faster, or it should not be that much faster that it increase the or insecurity of the code. Like it make the code insecure, it make the code or application completely insecure, that tomorrow if we release the code and it contain a huge vulnerability like a log4j, where the server can have an RCE, remote code execution server, can someone can acquire and can log in into our server and destroy the application, may put some banner on our website, e-commerce website. That thing we don't want. So that's why this DevSecOps is introduced. So the release cycle still remain fast, but at least remain secure as well. So here you can see in the planning phase, we introduce this threat modeling. In the coding phase, we introduce this static analysis, because static analysis happen on a code when the application is not in a running phase, it's into the code phase. Then there is SCA, which stand for software composition analysis, which take care of which libraries and packages this code is made from. Are those libraries are fine and secure, or they are insecure and contain vulnerability? Then there is a dynamic analysis, audit, monitor, log, detect, threat intelligence, and response is there. All of this topic will be get covered in the DevSecOps course. Any question till now? So taking
I
it as
have one question.
yes, Kamlesh.
Uh, so, so how we will do practicals in terms of doing it? Will it be only theory, or we would be
No,
doing
no,
some
no.
practical?
No, Kamlesh, it will be complete. Like I will keep this course as 30% theory and 70% of the practical. So few topic among these, like here the threat modeling is a theoretical stuff. It's more a thing which is actually being done on the pen and paper. There is no tool out for this, although there is a tool which is known as threat dragon. Still it will be like more of a painting stuff. Then there is a static analysis task tool, where we have to actually go and set up a code scanning tool. Examples are like Sneak is there, Sonar Cube is there, Veracode is there, which is going to scan the code and provide us the result. Okay, this code contain here's code smell, bugs or vulnerability, and then we will see how we can remediate them. In the build phase, there will be a SCA tool that we will implement. Also, we will implement integrate it with the pipeline, Jenkins pipeline, like how these all things can be automated without manual intervention. The fast release cycle will remain faster. So for sure, there will be practical, Kamlesh. There will be very less theory and more practicals. So hope I answer your question. So the first thing that we have is a threat modeling, which is done into the planning phase. So let's understand the threat modeling. Before understanding the threat modeling, we have to understand the threat first. So if in a normal language, if we take example of a real life, anything can be a threat, like thief can be a threat. If you are going on a road, rash driver can be a threat. So all those things are known as threat. But in a cyber security, threat refers to any type of malicious activity or attack that could compromise the confidentiality, integrity, and availability. Confidentially simply mean that the information that's supposed to be hidden and only needs to be available to few specific person. Only those person have the accessibility to that information. That's known as confidentiality. Integrity simply means like if I'm sending a message as "Hi Kamlesh, I have a problem. Can you please help?" That message should go same as it is. It should not go like, "Hi Kamlesh, I need something from you," or Kamlesh, I'm facing some issue. And whatever I'm writing, it should go with the same context, same everything without any change. That's not as that known as integrity. And availability simply means like the example I mentioned, that I supposed to have a server for 100 customer, but there are suddenly 500 customer came. So the server needs to be available. Number of instance needs to be increased. The capacity of the server needs to be increased. So that comes under availability. So this is known as CIA triad. Companies and interviewer might ask to you what is CIA triad. So that time you have to mention about confidentiality, integrity, and availability is known as uh, CIA triad. So just coming back to the threat. So in a cybersecurity term, any malicious activity, like if a user is attempting to brute force and a user is attempting to spread phishing mail to you, or hosting a malicious website, or sending a malware, all those things are known as threat. And moving forward to the threat modeling. So threat modeling is just a process of identifying and assessing this potential threat to a system or application. So our goal in the threat modeling is to identify these security vulnerabilities and bugs before an attacker come and exploit that. So if as a DevSecOps engineer, we have to be more proactive as compared to the attacker. So if I understand, okay, our system contain a vulnerability, we have to patch it as soon as possible before attacker understand, okay, this system is using Ubuntu and Ubuntu 2020.04 version have this vulnerability, and this application like e-commerce web application is using this feature, this library which this 2020.04 version have, and they are not updating it, let's exploit it. So we have to identify all those threats, and the process typically involve identifying the assets simply mean our servers, our DB, whatever we own is considered as asset. And like if that thing went wrong or that thing got attacked, that thing went down, our application, our organization, or our server got compromised, or application get compromised, all those things comes under asset, and the assets that need to be protected. The potential threat that could compromise them, the potential threat can be any vulnerability exists into the system, attacker performing the brute force attack. So all those things are known as potential threat. And the likelihood, so we have to understand this word likelihood in a deep depth. The reason being, this likelihood is like, what's the probability of that happening? Consider I have a server which is highly important to me, and that server have a vulnerability for which a patch is not available. Now, port 22 is open on that server to SSH into that server. Now, that server contain a vulnerability. Now, what's the likelihood or what's the probability of that server getting exploited? Somebody come and able to access to my server. What's the probability of that? So the probability totally depend upon how you have configured that server. If the server is in private subnet, then the likelihood or the probability getting decreased. Now the port 22 is only open for a VPN. Now the probability is getting more decreased. And consider instead of opening the port SSH port, like the AWS has another service which is known as AWS SSM that doesn't require you to open a port SSH port to log in into the server. That's a totally different concept. But if we introduce that as well, the probability of getting that server compromised is very less. So you understand what is likelihood. Likelihood is like if the vulnerability exists, but still what's the probability of getting that thing exploit. So if we go back to the definition of threat modeling, we have to identify the asset and the threat, potential threats on that asset, and as well as the what is the probability of getting those things that threat got compromised, or those threat can be exploited to gain access or whatever they want to do. So that's the definition of the threat modeling. Once the potential threat have been identified, mitigation strategies can be developed to reduce the element of the risk for those threats, which I already mentioned, like putting the server into the private network, or keeping the SSH port available to the VPN IP only. So that's how we can remediate those stuff. Now, threat modeling is a planning phase exercise, which I already mentioned to you that threat modeling is actually done into the planning phase. But threat modeling is more of theoretical stuff, or which can be easily done on a pen on paper, which require more and more brainstorming by you guys instead of depending on any tool. So the threat modeling is more of phase that is actually done into the planning phase, but it is from a security advisor, I will say that it's supposed to be done on every stage of SDLC. Let's take an example. On the coding phase, if we want to do the threat modeling, we can also do along with the SaaS tool. So that's one thing. But threat modeling require a bigger team to come into the picture and perform the threat modeling. So now performing the threat modeling require a strategy, how we can perform the threat modeling. There are multiple strategies available into the market, but the most famous one, which was introduced by the Microsoft, is a stride methodology. So it have 6 words, which is STRIDE. Each letter from the stride word actually stands for something. Here, if we go, S letter stand for spoofing, T stand for tampering. We will be understanding them into the next slide. So T stand for tampering, R stand for repudiating, I stand for information disclosure, D for denial of service, E elevation of privileges. So this triad methodology is a thing that we are going to use for performing the threat modeling of our application. And these are the things: spoofing till elevation of privileges. So let's understand each of them in depth. So spoofing simply means like I'm trying to pretend someone else to steal their data or money or to spread malware. Like I'm hosting a malicious website like random facebook.com with something. Instead of facebook.com, I have like facebook v2.com. That's a fake website where I shared those URL to you and you think, oh, it's a normal Facebook website, let's log in, and I got your credentials. So that's one example of spoofing, where I spoof genuine website. And another example is like, consider I'm using a banking application. I try to brute force a user there, and I got access with the help of some X email address and Y password. That's where that's also an example of spoofing. Another example is like I'm sending a malicious mail to you, to a victim, and sending some malicious link inside it. So that's also an example of spoofing. So here the same thing is mentioned. Attacker can also try to spoof himself by brute forcing the username and password in a website. So spoofing simply means, you understand, by sending this malicious stuff or trying to be someone else, pretending to be someone else, is known as spoofing. And to prevent from the spoofing, there are multiple ways. Like for the brute forcing, we can apply the MFA. So if the user even get my username and password, he still won't be able to log in, because MFA is protecting that. MFA simply means multi-factor authentication. After you have seen that in some of the website, they ask you to set up the MFA. So after putting your email address and username, you have to put a code. Either it's a OTP that you received on your phone, or it can be a code from a Google Authenticator as well. Another thing is account logout, like someone trying to brute forcing my account where the username and password. And in the website itself, I set a mechanism like, if somebody put my username and password 5 times wrong, please log out my account for the next 24 hours. So if somebody put my wrong username password for the 5 time, my account won't be accessible to anyone for the next 24 hours. That's one of the way of preventing this spoofing. Another thing is in security awareness training, which happen in every IT industry. How you can remain protected from someone spoofing himself as your manager, someone spoofing himself as a CEO to buy you to ask you to buy something, or hosting some malicious website. So all these things comes under this spoofing. The next thing that is known as tampering. So in a very small definition, tampering simply means tampering your data. So tampering refers to the process of modifying, changing, and updating or deleting the data in a wrong way to cause harm to the application as well as to the organization. Very simple. So it simply means like, consider there are some configuration files are there. If I change those configuration file, it's known as tampering, like changing those configuration file in a malicious way or in a wrong way, which is not supposed to be done by you or some user who is not belonging to the organization, who doesn't own the server. Are the example of tampering. Tampering of log file is also example of that. Like there's the application in which every activity is getting tracked and getting logged in a place, and someone went there and deleted those logs, is also known as tampering. Tampering is also can be done into the configuration, like network configuration or server configuration. I can give an example of this networking and server tampering. Like consider I have a laptop, after that there is a router in the loop, and after that there is a server. So all of my traffic is going through my router, and in between some genuine router. There is no malicious router in between the path. But I kept my router open, that some anyone who can able to connect to my Wi-Fi will able to use my router. I kept it like this. So somebody went there, connected to my Wi-Fi. My Wi-Fi password might be very we can say very weak, just a simple password string. Somebody logged in into my router, changed my configuration of the router in such a way that, okay, instead of directly sending it to the server, first it will send to a router which is actually hosted by the malicious actor, or we can say attacker. So all of my traffic which is going to the server, first it will go to my router. My router will send the traffic to the attacker's router, and from the attacker's router, it will be going to the server. So attacker will all be able to see whatever activities I'm doing. Even if I'm buying something, he will able to see my credit card details. So to avoid such things, we need to follow this. To avoid database and tampering, we have to follow the proper access control, least privilege principle. In the network tampering, we have to follow this proper password and access control. Same thing, access control here. So that's the second thing from the stride. Third thing is repudiating. Repudiating is something that we need to understand in a very funny way, that if I did something and simply I said, oh, I didn't do it. I'm not the one who actually made this transaction. I'm not the one who actually deleted this server. I'm not the one who fired this rm minus rf slash command. So to avoid such situation, repudiating also known as this as one of the thread where a user commits something and then he mentioned I didn't do it. Let's take an example of a organization where user and employee belongs to the operation team. So the operation team is not, I'm not talking about that operation team which take care of the server, another operation team which works with HR and take care of this off-site and take care of buying the identity cards for the users and buying the stuffs for the office. So they always have a company's credit card and company's account to make those transactions. So this, the bigger management will always remain free from this hassle. So consider a user come there and like one of the employee who's a rogue employee who made a transaction for himself from the company's credit card, and then he mentioned I didn't do it this transaction. I'm not totally unaware about this transaction. So just to be safe from this type of repudiating type of threats, we need to make the proper logs. Like we have to store the proper logs, like with the transactions, with the username, what's the transaction ID, which medium they use, did they use the credit card or they did it with the net banking. All those things need to be present. Like every type of log, whatever happening in the application, whatever happening into the organization, needs to be present somewhere where log can't be tampered. Those logs will be available to only few specific user and nobody can go and delete those. It's only read only access or write only access there. It's nothing like delete type option is there. That's how we can protect from this repudiating stuff. Next is information disclosure. So information disclosure, which I already mentioned, is one of the things from the CIA triad. I stand for this in C stand for the confidentiality, and this information disclosure directly impact this confidentiality of CIA triad. So consider in an e-commerce website, there is a dashboard for customer as well as there is a dashboard for the seller, where the seller can will have their all of the details, like how many products they have sold, how many amount they have earned, and how much Amazon took out from them. So all those details are stored in a place where only the seller can see. But some consider there is a functional mishappening is there into the code, that allowing the customer, like I'm a customer, I can also see the transaction and I can also see the profit of the seller, or each of the seller, whether I'm buying a product from the site, why I'm buying the product from the seller or not. I'm able to see the information inside information, the sensitive information of the seller, which I'm not supposed to see because there are not proper access control into the code. That's also an example of information disclosure. To avoid this information disclosure, we have to follow this cryptography. Like for consider an example of database, somebody logged into the database and able to see all of the details. We should use the cryptography over there. We should follow the least privilege principle. Like least privilege principle means like if I required only X amount of permission, I must have only X amount of permission. It should more not be like X plus one permission, X plus two permission, or some extra permission are not assigned to me. Another thing is follow user management and file management stuff. So if somebody able to see the file which are not supposed to be seen by someone else, like there we can see those file management stuff. This is how we can avoid the information disclosure. Now, another thing is denial of service. You guys are already familiar with DOS attack. If you are not familiar, let me tell you what happened in the DOS attack. So consider there is a server which is sending, which is getting a request from the legitimate customer. But I host a server that continuously sending the lot of amount of requests, like 500 requests every second, and the customer is the server remain busy in handling those 500 requests instead of serving the genuine customer's request. That's known as denial of service. So denial of service can happen in any type of application. So if it's just to handle the small amount of attacker or small attackers, we have to provide enough resources to the server that if a small attacker is there, we can expand our server so it can handle those load. Apart from this, we can install this firewall which will stop these nodes. Which will stop most of the requests at the firewall itself. Another thing is which is known as IDS IPS, which is known as intrusion detection system and intrusion prevention system to handle such situations. So moving forward, we have elevation of privilege, which is the last word of the stride methodology, which is elevation of privilege. Elevation of privilege simply means that a low privilege user gain access to the high privilege user account. High privilege user account. For example, a normal user is able to exploit the functionality in application that is supposed to be only belongs to the admin user, which I already mentioned. Consider in a e-commerce website, I'm a admin where I can go and delete the seller's stuff. Like as I found that okay, seller is not sending the right amount of products to the user. They are just using misusing our platform. So as an admin, I have a responsibility to go and send a notification to this seller and then delete his account. But if a normal user able to see the admin panel and able to delete the sellers from the e-commerce website, that's known as elevation of privilege. And to avoid such situation, we have to follow this proper authorization system to avoid this elevation of privilege. So proper authorization system needs to be there. So this is what we understand from this stride methodology. There are 6 different type of threats. All this SQL injection, XSS, all these things belongs to under these 6 things. So the next thing which is related to our threat modeling is known as trust boundaries. So in small definition is given for the trust boundaries here because we should know where should our trust boundaries lie. So let's go and understand the trust boundaries. So application which we have our application that we made, e-commerce website is there, payment website is there, or normal MDM type of website is there. Any website that we make, it's majority combination of multiple component from which few component belongs to us, few components belongs to third party. What I mean by third party, consider in my e-commerce website I have a payment gateway. I cannot set up a payment gateway, so I'm going to use Razorpay as a payment gateway for me, by which the customer can pay it and those amount get credited to my account or the company's account. So I'm not going to make a whole payment gateway for my. So I'm going to use a third-party service. So this application are made up of multiple things, third-party component, and some things are owned by us. For example, EC2 instance, DB, cert manager, payment gateway, all these things are component of an application. And trust boundaries defines what needs to be between our trust level and what things need to be out of our trust level. So uh, this application is made up of multiple component like servers are there, payment gateways are there. Among these things, few are the things which belongs to us, few things which belongs to the some other company or third party, which I mentioned as one of them is payment gateway. So we cannot trust the payment gateway. That's an example. We can only trust the things that we have created. So to create this trust boundaries, I'm going to show you an example how we can create trust boundaries. The three question you should ask, but the majority important question is this one only: who owns the system? This is the one which going to help you to define the trust boundary. Other two are also important, but this one is the actually which going to help you create a boundary. So is authorization changing, like any type of authorization changing between the component? Everything inside the trust boundary communicate inside the trust boundary only. So that's one thing. These three questions will allow us to understand the trust boundary better. So let's take an example. This is the e-commerce website. If you are familiar with cloud, you will be for sure knowing this things: CloudFront API Gateway, EC2, Lambda, SNS, S3 bucket. If you are not familiar, I will let me explain those things to you. So CloudFront is something which is like a front gate of an application. Here the CloudFront have a URL that allow us to reach out to the API gateway and then the EC2 instance behind them. If we want to remove the API gateway, we can remove it, but the API gateway allow us to handle this API better as compared to handling it through the code. Then there are EC2 instance. EC2 instance simply means servers. Lambda functions are there, which are serverless, which perform a functions whenever there is a requirement. Then there is a SNS topic and S3 bucket. So let me tell you a flow. S3 bucket is also a storage type mechanism which is provided from by the AWS. It's separated from the DBs. Consider this is an e-commerce website. A user came with the help of our domain. He just fired a domain www.ecommercewebsite.com. With the help of CloudFront, it reached to our application, application dashboard. And after logging into the application dashboard, he bought something, add something to the cart, and made the payment through the payment gateway. All of this transaction, whatever the activity that he did, is getting stored and getting observed by our Lambda function. And after observing, if the Lambda function find that okay, sir, person buy something, I need to send a notification to the seller. They send a notification with the help of SNS topic. It's a simple notification service from the AWS. If they need to store everything into an S3 bucket, every logs, like whatever the user is doing here, get logged into this S3 bucket. This is a the flow of this e-commerce website. Now, the thing that we can trust. Here is the user. Can we trust this user? The answer is no, we cannot trust this user. The reason behind this is the user is totally out of our control. We don't know this user. Anybody can come and sign up on my website and buy stuff from me there. So this user is totally out of our control. And instead of a normal and legitimate user, there's a high chances that an attacker can also come and host and start doing malicious stuff here. So we cannot trust this user. Here we will create a boundary like this. One dotted line we will create. This is one thing we cannot trust. Now the another thing is CloudFront. CloudFront belongs to us. So we can we hosted this CloudFront and we made the configuration of this CloudFront. So we can trust this CloudFront. Same goes for the API gateway. We created this API gateway. It hosted in our environment. It's although publicly available, public is something which is supposed to be public, but still it belongs to us. Every configuration is made by us. So this is something we can trust. Then there is EC2 instance, which belongs to our VPC. It's in private network. Is the configuration, the accessibility all belongs to us. We are the owner of this machine. That's why we can trust this as well. Then there's a Lambda function which we can trust. There's a SNS topic which we created, we can trust. S3 bucket which belongs to our account, we can trust. Now there's a payment gateway where the user is making the payment with the help of a payment gateway which we didn't host it. It's something a third party service that we are using. So can we trust it? The answer is no, we cannot trust it. So we will create a boundary here as well. So if I go to the next slide, here you can see I have created two boundaries. Things like here, the things we cannot trust it are on the left side, things we can trust are on the right side. Here, the payment gateway we cannot trust. That's why we created a boundary here as well. Now, if I have to make a box or make a single unit that we can, things that we can trust is look like looks. The things that present in this box, these are the only thing which are hosted by us. These are the thing which we own, and all the configuration here we own. So that's why all these things belongs to us, and we consider them as our this blue dotted line as our trust boundary, and these things belongs to our trust zone. Now, next thing, the trust boundary we understand the how we can create the things, and we can understand which things belongs to us and how much we can trust those things. Now, the same thing, similar to the trust boundaries, is trust zones. So trust zone is very simple, but majority of the company only use the trust boundary. Trust zones are used very less as compared to the trust boundaries. So trust zone have the same concept as trust boundaries, but with the twist that instead of boundaries, like the boundaries are the lines, we have zones here, and zones are rated from 0 to 9. Like 0 stand for the least trusted entity and 9 stand for the most trusted entity. It's just a scale from 0 to 9. Instead of 1 to 10, it's just a scale from 0 to 9. Like the 9 for the most trusted entity, the thing that we trust most, and 0 stand for the thing that we trust the least. So user will always have a least trusted entity, and DB will always be the highest trusted entity. The reason being that DB is actually something which is always remain private. There are very less chances that DB become public. The DB is supposed to be always private. The data inside the DB is always encrypted. Like some companies forget those things, so they don't encrypt it. So in short, there's a concept from the trust zone that we need to specify 9 to the DB. Now, taking example of this normal application where a user is there. CloudFront is their API gateway. In the API gateway, there is a functionality of login as well as sign up, and there's a SSODB which store all of the details of the user. Then there's a EC2 instance on which our application is hosted, and then there is our DB in which everything related to whatever the activity which is happening is getting stored here. So there are two DB, one for user, one for activity. Now here, the user which I already mentioned into the trust boundary, we cannot trust this user. We will simply give 0 here. And the thing which I already mentioned for the DBs, we always give 9. So this DB will get 9, this DB will get 9. Now consider the example of this CloudFront. CloudFront is something which we own, but can we trust it? Yes, we can trust it, but how much? On the scale of 0 to 9, how much we can trust it? This is something which is public. This is something that can be impacted by the user by sending the malicious request. This is something which is public facing, which is available to everyone. So that's why but still we own it. That's why we will give it a marking and the trust zone of 1. Now moving to the API gateway, API gateway is behind this cloud front, so it's little bit inside, little bit private as compared to the cloud front. So we will give it as a rating of 3. Again, gone for login and sign up as well. This functionality belongs to the API gateway, so we will give them 3 and 3. Now this EC2 instance is the only thing which left. So for this EC2 instance, how much rating that we are going to provide? The EC2 instance belongs to us, but it's in private network. SSH port is only open to VPN, and it's encrypted. Everything on this disk is encrypted. But still, the libraries that EC2 instance is using might get out of patch, and we need to perform the patching, and we need to do some security stuff on it. So that's why we will give it a rating of 5. It's the least trusted entity. It's something that we can trust extra. Something we can trust extra more as compared to the cloud front. Then there's a login functionality which belongs to the API gateway. That's why we gave it 3. Sign up functionality again 3. Then EC2 instance we give 5. DB we give 9, and SSO DB we also give 9, which I already mentioned. The DB and DB have the highest trusted entity, and user is the least trusted entity. Now we understand this. Now, there are 4 questions that you should always ask while performing the threat modeling. And among these 4 questions, top 3 are the uh, most important one. Like, what are we working on? What can go wrong? What are we going to do about it? And did you do an acceptable job? So this question we will be asking with the help of example. So we are on an example where we are going to perform this threat modeling here. So consider this in user, which a banking application is there. User is there, banking application is there. So user login, the login details, the username, password, all those things are stored into this DB. Even if the user sign up, all these details are stored into this DB. After login, he have the functionality of transferring the amount. He have functionality of changing the password. He have functionality of deleting the account. Or and all these things, this change password stuff is getting stored into the S3. Now we already discussed about stride methodology. That a stride methodology exists. The first thing of the stride methodology is this spoofing. So there are multiple things that can happen here in terms of spoofing, but we are going to take only one example, and I will from each of these 6 categories, and I will also suggest you a remediation step how we can remediate the things. First thing is someone went there as a normal user and login, but consider an attacker came and start brute forcing the username and password here into this login field, and somebody able to gain the access. Then it's a security flow, security vulnerability where we were not able to stop the brute force. So that comes under spoofing. That's an attack come under the spoofing. So how we can remediate them? We can remediate them with the help of implementing a MFA or lockout. That's one of the threat that we are able to identify in this flow diagram with the help of stride methodology. If we take the example of tampering, consider someone sign up from here, and after sign up he log in, and he able to access the DB. Somehow the attacker is able to access the DB and tamper the DB details. The DB contain the username and password of every user who are supposed to be on this application, who have signed up earlier on this application. And the new attacker came, sign up, and then log in and able to tamper this DB. Then this comes under the tampering of the stride methodology. To avoid such situation, we have to follow the least privilege principle where a normal user won't be able to access the DB. That's come under tampering. Here, if consider the third example, third threat, if a user comes, log in, and transfers a amount to its family member or someone else, and then so he went to the bank and mentioned that, okay, I never did this transaction. So here you see there is no arrow between transfer and the S3 bucket. So these logs are now not getting stored into this S3. So no transfer logs are getting stored into the S3. Same goes for the deletion. No deletion logs are getting stored into the S3. So if the user even said that I didn't do it, we will never be able to, the bank will never be able to prove that he is the one who actually made the transaction because no logs are getting stored. So this will come under the repudiation, which is a third letter of the stride methodology. After that, we have this information disclosure. Consider a user came and log in, and then he transferred some amount, and he's supposed to see the transfer details of the transaction that he made. But application with the error pop out every transaction that every other user made. So he have the details of every other user, how much money they have transfer and to whom they have transfer. All those details came in front of him. That's known as information disclosure. And to avoid such thing, we need to set up a proper access control mechanism. After that, we have denial of service, like somebody user came and then he made a transaction, and he put a DOS mechanism on the transaction, denial of service, by continuously sending a same amount of money, like he is sending 0.01 paisa to someone else, and he automate this process to shut down this bank application where the bank application won't be able to respond to the legitimate user. He automate this transfer money request with the help of some automation tool and start performing the DOS on the application. To avoid such situation, we can set up a number of transactions per day for per user. Like he should be allowed to at least make 20, 10, 5 transactions per day. That's how we can stop the denial of service in one of this vulnerability, or we can say one of this threat. Now there is elevation of privilege. Now everything is getting stored into this S3 bucket. Consider if a user came login and he is able to access this S3 bucket and able to delete the data out of it, able to delete all of the transaction logs out of it, then it will become a difficulty over there, like how we are going to maintain this elevation of privilege. So there should be some strict access control that won't allow any random user to go and delete the S3 bucket. So this will come under this elevation of privilege in this stride methodology. Now you have seen that I have discussed one example from each of this stride methodology. Now, if we have to capture every type of thread that can be available in this application from the stride methodology, here's a whole sheet in front of you. In the spoofing, these type of attacks can be possible, like SQL injection can be possible, which can be remediated with the help of using parameterized query. Access is there, which can be eliminated with the help of using validate and sanitizing the user input. Tampering is there, log tampering can happen, which can be remitted with the use of immutable logs where nobody will be able to change the logs. Repudiation is there, which can be like deletion, denial of account deletion, denial of actions. All those things can be solved by enabling the logging. Information disclosure is there, exposed logs is there, transaction detail exposure, which can be solved using access control to the transaction detail. Then there is a denial service, like anybody can randomly go and flooding the transaction processing, flooding this password change, and there is a rate limit password change request, use captcha to provide to prevent overloading. So here are all of the issues that can be present into these categories. Allow me a minute. That can be present into these categories, and here is the remediation steps for them. So this is how we can perform the threat modeling by implementing and discussing the stride methodology while performing and evaluating all of the flow of the web application. So that was all about this DevSecOps and this threat modeling. So this is thank you from my side. If anybody have questions, they can ask. So taking it as a no. Uh, Thanks for being here and thanks for thanks for seeing this PPT. Thank you very much.